In this module, we're going to look at precipitation reactions. By the end of this module, you should be able to write a precipitation reactant given two ionic compounds, be able to identify the product, and balance the resulting equation. Now that we've looked at the solubility rules and can identify what compounds are soluble and which ones are insoluble, we can actually look at our first type of reaction, which is a precipitation reaction. So a precipitation reaction is one that results in the formation of a precipitate. And a precipitate is just a solid that separates out from the solution. Frequently, when you hear meteorologists on the news, they talk about precipitation. They talk about water or snow coming out of the sky. Well, what we're looking at here is solid coming out of solution. And we're going to use our solubility rules that we've covered to determine the precipitate or the potential precipitates in our reaction. Let's look at an example. We have two compounds here, ammonium sulfide and copper nitrate. These are both soluble compounds. Note that we have our ammonium ion and a nitrate ion. So we have two soluble compounds. So these are listed as being in the aqueous phase because they're dissolved in water. Now what I need to do is figure out what the potential products are. Remember that if I have a cation, such as ammonium, what I know is that it cannot be paired with another cation. It can only be paired with an anion. And I see that when it's paired with a sulfide, it's aqueous, it's soluble. However, I have to look and see what the other compound is, and in this case, it's going to be nitrate. So I could form ammonium nitrate. Now notice that I did not bring the subscripts with me because I know that the charge on ammonium is +1, the charge on nitrate is -1, and so I go back to what I learned in dealing with ionic compounds and see that the formula for this compound will be NH4NO3. So this is one of my potential products because it pairs a cation and an anion. Now I can look at my other potential product and I have one cation and one anion remaining. So it has to be copper. It can't be with nitrate because it came in with nitrate and we already know that compound is soluble. So the only other option is to pair the copper with the sulfide. And so what I see is I get CuS. Now remember, copper in this case had a +2 charge. Sulfur had a 2- charge. So when I crisscross down, I would end up with Cu2S2, which I can then simplify to CuS. Now what I have to look at is determine whether or not these two potential products are soluble or not. When I look at ammonium nitrate, both of these ions fall on my always soluble list. So I'm actually going to write this as aqueous, meaning this compound will dissolve in water. For the CuS, I know that my sulfides are insoluble, and so I'm going to write this as S for solid because this is going to be my precipitate. When I put ammonium sulfide and copper nitrate in water, these compounds are going to dissociate completely because they're ionic compounds, therefore they're strong electrolytes. And basically they're going to try to find another ion that they can pair up with and as a result precipitate out of solution. And the only pairing of ions that can do that are the copper and the sulfide. And so we do get a precipitate out of this reaction and it is copper sulfide. I still need to go back and balance my equation because I notice that I have two ammonium ions on the left and only have one on the right. So I add a 2 in front of the NH4NO3, and that also resolves the issue with the nitrate that I have two nitrate ions, and now I have two nitrate ions on the product side. For copper and for sulfide, I have one copper and one sulfide on the left. I have one copper and one sulfide on the right. So I now have a balanced chemical equation which shows me the precipitate from my reaction. Let's look at another example and see what our potential products are. The first thing we need to look at are our original compounds. We have sodium sulfate and magnesium chloride. These are both aqueous substances. Our sodium is always soluble. Sulfates are soluble. This is not one of the exceptions. And our chlorides are soluble, and this is not one of the exceptions. So I have two soluble compounds, which means these are going to completely dissociate in water. So I'm not going to have units of sodium sulfate in water. I'm going to have sodium ions and sulfate ions. Likewise, I'm going to have magnesium ions and chloride ions. So now I need to find if there's any other potential pairs of ions that could form a compound and if that resulting compound will be soluble or not. I notice that sodium is my cation here in the sodium sulfate and it's paired with sulfate. We see that that's a soluble compound. Our only other option for sodium is to pair it with chlorine, and so we could potentially form NaCl. And we look at our other potential compound. Here we have magnesium and we have sulfate, And so I can write the formula down for that as MgSO4. Now for sodium chloride, I see that it is soluble in water, and so I mark that as aqueous. I also see that for magnesium sulfate. Sulfates are generally soluble, but magnesium is not one of the exceptions. And so as a result, I actually have no precipitate forming, and so I have no reaction occurring because there's no change in the reactants and products, because everything, all of my reactants and all of my products are going to be dissolved in water. They will be dissociated completely into their ions. In this reaction, we're going to look at the formation of a precipitate. When we look at two aqueous solutions, in this case we have calcium hydroxide, which is an aqueous solution, and cobalt nitrate, which is an aqueous solution. They are going to react to form solid cobalt hydroxide and aqueous calcium nitrate. So we're actually going to see the solid forming from these two aqueous solutions. So I'm going to pour the calcium hydroxide into our beaker. And then I'm going to add drops of our cobalt nitrate, which is a purple solution, and we should see the formation of a precipitate. And we see that it is a blue precipitate. What you see going to the bottom is actually a solid forming from the cobalt nitrate and the calcium hydroxide. In the next module, we'll continue on with this idea of equations, and we'll talk about molecular, ionic, and net ionic equations.